Hi there. So in this video, what I'm going to be talking about is something that is very important from a media buying perspective. Most media buyers, I've seen from my experiences as a performance marketer, as a media buyer, make assertions to their stakeholders, to their bosses, to their managers, and to themselves, above all, that you know suppose during a festive season, during a seasonal peak, there's been an increase of sales, and they completely attributed, or at least the majority of it, they will attribute it to increased ad spends or basically the ad spend that's going on in that period, even if it's not necessarily increased. The problem with this, I think intuitively you can understand that when it's peak season or when there's an increased demand, uh, there is there is actually a part of the sales which should be attributed to that. So how much of it should be attributed to that is a separate question, but we have to first understand the problem theoretically, and then try and see how we can sort of find out what part of it truly is because of a sales, or rather, which part of the sales is truly because of ad spend. So this is basically the fundamental problem, as we say in causal inference. So causal inference is an emerging field in the context of marketing. It has been around for a really long time in natural sciences and medical sciences, but it has already been applied in social sciences by economists, for instance. Now it is becoming very popular in marketing as well. And one of the reasons we can see already, just because of the nature of the problem that we just discussed, the concept of attribution, the complexities around it, has necessitated the use of more advanced econometric methods like causal inference. So causal inference is first of all a school of thought. It's just a thought process before being, it's better to think of it as a thought process rather than just a set of methodologies, which it is, of course, as we'll see. But let's actually try to understand this problem within the framework of causal inference. So there's going to be some mathematics involved in it, and it's important to kind of pay attention to that. So this is basically the original equation that we're going to talk about. The causal inference uh, talks about things in terms of effects. Okay, so there's a treatment and then there's an effect. So you can see that on the left-hand side of the equation, we have what's called the observed difference in outcomes. And then I'm coming to that. And then we have it as the sum of two things, the treatment effect on the treated and the selection bias. So what I was really talking about at the start of the video is that when you're trying to attribute the entire increased sales from during a seasonal peak, during a peak season or festive season to ad spend, I was really suggesting that it's a problem of selection bias. So how do we actually arrive at this point? We are using this equation here. So the observed difference in outcomes means that suppose you have taken an action, okay, and you had a pre-treatment, right? Before we take the action, there was some sales, right? So before you had the campaign, for instance, you had sales, and then you also have sales after that. So what is the difference in the outcomes between the two? Right? So you see how this has been written. So this is using the concept of conditional probability or probability in general, right? So um, it's basically being restructured a little bit, but uh, as you can see, the kind of notation that is used is very similar to conditional probability. On the right hand side, we have the treatment effect on the treated. Okay, so just to give you an idea what's really going on here. So obviously this pipe symbol, as you understand, is basically indicative of conditional probability. So this is the expectation. Um, so expectation of yi. So yi is your outcome, right? Uh, and then your di is the treatment. So treatment is really in this case, we are taking it as high as well. So this is any kind of intervention. This is any kind of uh, anything that you have that has been actively done, right? So that's why it's an intervention. So you can call it a treatment. So one stands for high aspend, low for low aspend. So you see that when d is equal to 1, it means that when it's being subjected to high ad spend, and we are going to treat a high ad spend period as the festive period, as a special period, okay? And then we get to treat d equal to 0 as a low ad spend period. So yi equal to 1 means that what is the expected outcome when the ad spend was high. And similarly, you're deducting from it the expected outcome if the ad spend was low. And you can understand already why this would be the observed difference in outcomes, right? So that is the observed difference in outcomes. This is not actually, sorry, this is not the expected, this is the observed difference. The expected are on the right hand side here, where we get the expected value. So what is the expected value? Uh, what is the expected outcome, sales value, when you actually have a high ad spend? And from that you deduct what is the expected value when you don't have a high ad spend. Okay, so but the condition got a high got a high got a high ad spend, right? So that's of course the real condition. So this part here, uh, this is a very interesting part because this y0, this actually stands for the counterfactual. Okay, so the counterfactual is something that did not happen in reality, but what would have happened if that intervention hadn't occurred in the first place. So this is the basis of causal inference. This is where we can try to truly understand the cause of something when we try to when we are able to estimate what would have happened without that thing ever happened. Okay, so let's think of it. You can think of any problem in the real world actually. Just think of it. Like I don't know. So suppose if World War II wouldn't have happened, where would have world history gone? Okay, it's a huge question. It's a very loaded one. But the point is to think of that is to think of a counterfactual, and to think of a counterfactual is to have a causal inferential approach. So by and large, therefore, it starts with the thought experiment. So the thought process is very important in this sort of an approach. And while this gives the treatment effect on the treated, as you can see, it's on the treated because it's t equal to 1 here, right? In the condition of the conditional probabilities, it's always t equal to 1. So you're basically subtracting the counterfactual from what actually happened. So this left part on the left hand side is simply what happened, right? So it's what you expect when the treatment is 1 under the condition for that it was treated. So that's exactly what happened. We know that there was a treatment, and this is also something that we have been able to observe. From there, we just deduct uh, the treatment effect, the counterfactual rather, and to get the treatment effect on the treated. But apart from that, there's also a selection bias. So this selection bias part here, as you can see, it gives us the difference between what would have been the case if there were no treatment, but under the condition that there is actually a treatment. And it's also deducting the part where where it's absolutely untreated. Okay, so the expectation when the expectation of sales when when the campaign has not been applied at all, when there was no treatment. Okay, so the difference between these two gives you selection bias, and the sum total of the selection bias and the treatment effect gives you the observed difference in outcomes. The problem that's happening when any performance marketer or media buyer is saying that it's only the ad spend that is leading to the increased sales during a special period or a festive season or a seasonal peak, is that they're leaving out the selection bias. They're only looking at the treatment effect, and this is the problem. And you don't take the right decision because of that, because you're leaving out a very important part of this equation. So you can see we can talk of it in this way. So it's expected sales given high ad spend minus expected sales given low ad spend. Um, and so this is the problem. So you attribute the difference in value to ad spend, you increase ad spend because it was a festive season. So here's the point. You actually increase the ad spend because it's a festive season, right? That's the whole point. You think that it's going to bring you more sales, but you increase the ad spend generally. It does not necessarily have to be an increase for this approach to work, or it can still be just the regular aspect, but at the same time, yeah, this is easier to sort of to understand because there has to be a special intervention, right? So it could be like a festive season campaign, a special campaign. So yeah, so in this equation, the observed difference in sales is there for this part here. We already saw that, so it's YIDI equals to 1 minus so this is the observed difference, sorry. So this is the left hand side. So you see that it's the difference between when you actually have the expected, the observed when there is a campaign and the observed value of the sales when there is no campaign. So uh, this is the part that is giving you the observed difference. But what's really happening is that you also have the selection bias apart from the treatment effect. All right. So the selection bias term captures the fact that those who got high ad spend would have had higher sales even without the ads. So that's the whole point. Right? This kind of gives you an idea of what would have happened even if there was no campaign. Would you have still got sales and how much? So that is being quantified by the selection bias part. Okay. So let's break it down a little bit. Why this reflects the selection bias? So we chose to increase the ad spend, right, during the festive season when people are more likely to buy. So let's see this now. Let's break apart this particular part of this expression, which stands for the selection bias, right? And let's just talk about it a little bit more. So expected value of sales when there is no when there is low ad spend rather, um, but on the condition that there is actually uh, you know a festive campaign or there is increased ad spend. So this is essentially a counterfactual. So this is on the sales under low spend. So if you have spent low during the festive season, it's naturally higher because the demand is up. Okay. So what this really means is that uh, this sales would have been higher anyway. This is something that you understand from logic, right? Because we know already from a fact that the demand is always higher during festive season. Obviously, we are not going to try and prove that here. There's no point reinventing the wheel. That is known for a fact. So that we have isolated that part of the of this entire toolkit. The whole reason why we are using this framework is because we are able to isolate these as separate variables. So this part here, this conditional probability part here, this little thing, the CY01 Y0I given vi equal to 1. This is the one which is giving us that part which says that your expected sales, your baseline expected sales during a festive period, irrespective of whether or not you have the ads running or special ads running or increased ad spend, whatever, would have been higher than the previous period. So there would have been a growth naturally, even if you didn't have the ad. And then you have the other part, which is sales on the low spend during regular season. So, like I said, remember at the start that di equal to 1. So, this is the binary that we have to create. So, higher ad spend corresponds to special season, lower ad spend corresponds to regular season. So, under regular circumstances, the sales would have been lower. So, we expect this to be lower. So, what this means that this is the positive value. The whole point of this discussion is to arrive at this conclusion here that you have a positive selection bias. So, you're missing out a significant part. And obviously, you can understand the higher is this part, the higher is the delta in expected sales, between a seasonal peak, between a special season and the normal part of it, the regular season, the normal part of the year. The higher is the delta, irrespective of ad sales, the higher will be this value, right? And the higher will be the selection bias. So this is not dependent on the campaign itself. Although, I mean, in a general sense, you can say that, okay, even that delta is kind of like a baseline and that will probably have some impact of long-term media effects. I agree. I'm not saying that it doesn't. I'm not saying that, it's completely independent in every way you can think, but from a restricted, controlled sort of environment within which media buyers and performance marketers have to take decisions, I think it is safe to say that it's a bad idea to sort of ignore the selection bias. First of all, it misleads the stakeholders. It misleads they mislead themselves as well. They can take wrong budgeting decisions. They can probably invest that money elsewhere, right? So suppose you had an extra revenue target. If it's supposed to $100,000, you've reached $100,000 or $1 million, but you're still investing in the ad spend, and getting output which you would have received anyway. Think of it this way, then you would have invested that money somewhere else more profitably. And right? In a financially more justifiable manner. So this is the entire thing here. The objective of this discussion is a quick introduction to the problem. As you can see, there is some mathematics which is important to understand. By the way, I'll just introduce you quickly to some of the really good resources that I've been going through. I seriously encourage anyone in this field to sort of go through these books. So this is an econometrics book. I don't know what kind of courses this is taught in, probably PhD people or people in economics, masters and all. But uh, it's not the entire book, but this is a book on causal inference, and I got myself introduced to this problem through this book, right? I was spending time on it, and it's incredibly well written. They give some incredibly good examples. Um, so Joshua Angress, by the way, is a Nobel Prize winner. Okay, so you're reading from an absolute stalwart in the field, and the great the great thing about these kinds of resources is that it will really open your mind. What you will really know from them, what you'll learn from them is the thought process. That's the most important thing. You learn to ask the right kind of questions. By the way, it has a watered down version of it, which I haven't yet read in detail, but uh, there is a sort of a easier version that I've written, as a sort of a companion to that book, and that's called Mastering Metrics. So you can also refer to that. Um, Great. So, I'll now talk about a couple of solutions. Okay, so we have talked about the problem. We have talked about the situation where media buyers end up overlooking the problem of selection bias. So, how do we solve for it? How do we calculate the selection bias, or uh, how do we actually, properly take decisions in this sort of situation arises? So, the best situation always is to do an experiment. Okay, the best solution. An experiment is something that's it's taken from the natural sciences. It's completely controlled environment. You have controls in place, and you know that whatever data you're getting is reliable. The problem with marketing, just like a lot of other social oriented sciences, is that there are too many variables which we can control for, right? So it's not like a natural lab for biology or chemistry. So it's very difficult to carry out experiments. That doesn't give a justification to not do any at all. Of course, with limitations, as long as you know your limitations, you can still sort of mathematically uh, account for them in some ways. But even beyond that, there are some limitations. There are some challenges of running experiments. There are costs associated with it, and both direct costs as well as opportunity costs. So sometimes it's just not possible. Okay. So what to do then? Do we completely, just resort to guesswork? Go back to our earlier methods that we started this entire exercise, criticizing? Not really. So there are some other methods when random assignment or so random assignment is the basis of experimentation. They randomly assign groups to control and variation, or control and test groups. Um, so yeah, that is a challenging thing to do sometimes. For what reasons we can discuss later on separate videos, or you can read it up yourself. But when that's not really possible for whatever reasons, due to feasibility or otherwise, you can resort to some solutions which are called quasi-experimental solutions. So some of which are actually influenced by the causal thinking, the causal inference approach. So I'm just introducing you to a couple of methods here. So that's regression with controls, difference in differences, propensity score matching, instrumental variables, and fixed effects models. So among these, one of the easiest to understand is probably the instrumental variables, but as you can see, it's written here. So this means that it's a variable that affects ad spend but not sales directly. But the thought written with a bracket is very crucial. It's very hard to find. So these are variables which, this will basically allow you to account for the additional effects like, selection bias. So you're going to be using a variable that does not affect sales directly, but affects ad spend. So that kind of solves your problem of selection bias. The instrumental variables can be a very useful method, but the only problem is that they're very difficult to identify or find. Difference in differences is a much better method. You can do comparison in sales, before, after, So this depends on simply doing an analysis on a before after. The ad spend has increased. Okay, so this can be very useful, and you can control for trends. So it's a very useful method. This is the method that I will be explaining shortly in a separate video as a sort of an extension of this explanation of this discussion. But I hope this was useful. This is something that's going to really arm you with a new kind of thinking. I know this might not have been super easy to understand or follow, but this entire thing, the treatment effect, the observed difference in outcomes, and selection bias, this terminology or this framework is super useful, when you're going to solve problems like this. So there's actually a really cool app here. I will explain that separately as well. So here you can run a regression like this, which includes some variables which ultimately matter. So there's this treatment, there's this post intervention, and then there's an interaction variable between these two. And this combined effect of this group and intervention, ultimately gives you your difference in difference analysis. So this is one way you can sort of understand the effect of multiple variables which you were missing in the case of selection bias. So I'll talk about that difference. There are a lot of other resources here that I'm just going through, and you can take a look at these books as well, causal inference, mixtape. If you want to take a look at some of the definitions that we've talked about. But yeah, I would definitely encourage you to take a look at the chapter, the very initial chapters, the experimental ideal part for the selection bias, and try to see if you can make some sense out of it. Great. So I'll actually stop here. I think this has been pretty interesting, hopefully to you as well. Trying to establish why there is a positive selection bias using the concept of causal inference in the case of the assertion that ad spend is leading to, or increased ad spend is leading to increased sales rather. So if you have any questions regarding that, do let me know in the comments. The more practical versions of it I'll discuss in upcoming videos. So do stay tuned for that. Thanks for watching.